Hello again. In this video we're going to look at structured bindings and custom types. C++ 17 allows us to use structured bindings with our own types, as well as some of the library types. We could, for example, have a struct and a function which returns an object of this struct, and then we can use a structured binding to extract the members from this returned object. So how do we do this? We need to implement the get function by index for our type. So presumably this will require a function which is templated with the index as the template. This will take the object as argument, and then somehow it'll decide which member to return. From C++ 14, functions can have a return type of auto, which means that the compiler will deduce the return type. In C++ 14, this had to be the same in all branches through the function, but in C++ 17, the branches can return different types. The traditional way of doing this was to use template metaprogramming with sfine and enable if to return a different value for each instantiation, and that's pretty horrible. In C++ 17, you can now make your life much easier by using constexpr if. And there's also another option actually. You can also return a variant object instead of having a return type of auto. So if you're very certain about what types you want the function to return, you could use variant. So here is our implementation of the get function. It has the index as the value parameter. The return type is auto to be deduced. We make this constexpr, so it'll be available at compile time. We take the object by reference as the argument, and then we use if constexpr to do the branching. So that'll return the appropriate member for the index value. So let's try that out. Here is our struct, our custom type. Here is the implementation of get using constexpr if to decide which member to return for the index. We have a function which takes a test object and uses a structured binding to display the members, and another function which returns an object of this struct. And then we can use a structured binding on the return value, and we also call the other function. And that works as expected. If we want to get really serious and give our class the full tuple experience, we can define some type traits for it. If you're not sure about this, or if it goes over your head, then don't worry about it. This is for people who want to get a bit deeper. If you're just writing applications, then it's very unlikely that you'll need to worry about this. The library has some type traits for tuple-like objects. Tuple size will give the number of elements in the object, and tuple element will give the type of the element with index n in that object. The standard library comes with specializations of these for the tuple, pair and standard array classes, and we're also allowed to specialize them for our own types. And this is very unusual. Normally you should never ever touch the standard namespace, but you are allowed to add these specializations. So the code would look like this. For the tuple size, we override the integral constant, giving it a type size t and value 3. For tuple element with a index parameter, we provide the type that corresponds to the index parameter. So 0 corresponds to int and so on. And then we can use this to write, for example, a function which returns the last member in the object. I've put the tuple size definition here again so we can refer to it. We have our getLast function which gets the last member. We start off by finding the number of elements. So we use the value member of this trait, which will be 3. So this will be replaced by 3. We then check that we do actually have some elements. The static assert will cause a compiler error if the argument is false. If you remember, with constexpr functions, there's no such thing as undefined behavior. Either you have well-defined behavior or you have a compiler error. So if the size is 0, the compilation will stop. If it's not 0, then it'll continue, and we can call get with the index of the last element as parameter. That'll be size -1. So let's try that out. We have our custom class again and the get implementation. Then we have our type trait specializations for the tuple elements and the tuple size. And then we have our function which returns the last member of the object. And finally some code which will call this function. And there we are. The last element of the test object is 3. Okay, so that's it for this video. I'll see you next time, but until then, keep coding.